So I think in the morning we covered this part. Who was here in the morning? Only you. This one, enthalpy of air with yes, in English units or US units. Okay. Now let's solve one problem. What is the relative humidity and humidity ratio of air at 80 degree Fahrenheit dry bulb and 50 degree Fahrenheit? Is this thing? Dew point. So there is air whose dry bulb temperature is given and also dew point temperature is given. And the barometric pressure means atmospheric pressure, total atmospheric pressure. That is total atmospheric pressure, PT, is given, dew point and dry bulb. We need to find out its relative humidity and humidity ratio. Relative humidity is given by vapor pressure, actual vapor pressure divided by maximum, which we represent by Pg when it is saturated. But at same temperature, we are talking about at same temperature. Now which temperature, 80 or 50? Which temperature, at what temperature? This is the definition of relative humidity. The first one, dry bulb. Okay, now we need to find out these two. Okay, now let's see. Let's show it on TS diagram. TS diagram is not shown here on slides, so it should be shown to understand it. Okay, now the air temperature is given as 80 degree Fahrenheit. So it means air somewhere is here. For the same air, dew point is given. So how to show the dew point? So is dew point, where is the dew point? Yes, so I have to follow which line? Constant pressure line. So if I show a constant pressure line, so this will be dew point. So it means this is given. For this air. If this air is cooled at the same pressure, so it will start to condense. This is given 50 degree Fahrenheit. But according to our definition, we want to find out relative humidity. So this relative humidity is given by this pressure and here this pressure. That is relative humidity, which we want to find out for this air which is here. Let me say it is 0.1. At that temperature, relative humidity is given by this P V divided by this P G. Now how to find these pressures? Steam table, yes, so I can find this PG at, yeah, that represents P set at 80 degree Fahrenheit. So I can go to the steam table, I can read this PG, which is P set at 80. What about this one?
It's the same, P set
at 50. Yes, this pressure is actually P set at 50. So this will be P set at 50. So go to the steam table, find out P set at 50. This will be what? PV. And this will be PG, which we need for relative humidity. Any question? Because without TS diagram, you will not be able to understand. I cannot understand. And TS diagram is not meant. That's why I thought I should record this part. Okay. So if this is clear, then that's what we have. It is done here. So this is the pressure, actual pressure, that is the saturation pressure, but at what temperature? 80 degree Fahrenheit. But this one we calculated from 50, right? This one. And this one, this is the saturation at this point. This properties of saturated steam. Now it is British units, English units, Fahrenheit, PSI. So what is PWS? It is this 0.178, this one. What is PWS? 0.5069. Again, we should show it, otherwise it's not clear. That is 70, that is 50. So this one, 80, sorry, yeah, 80 and 70. So at 80, this is PWS, and this one is equal to this one. That's how you will find relative. Just put values of these pressures multiplied by 100, because we show relative humidity in terms of percentage. Second, how to find out specific humidity. Specific humidity we are representing with our humidity ratio, omega or W. The general definition is mass of vapor divided by mass of dry air. Amount of water vapor per unit mass of dry air. The same, what we did, we use here ideal gas equation, and we can write the same thing in terms of pressures, PV over P of dry air, and here you have that ratio of R's. I think 0.622 something. Okay. So now what is PV? This one or this one? Yeah, for the same air, I want to find out specific humidity. 50. This one. This one. So this is PV. Because mass is not given, so we have to use pressure. And what is dry air pressure? Air. But that is total pressure.
This one minus.
So it means I want to find out P of dry air means P of total minus P of vapor. This one 0.5. No, sorry, 0.17. So it will be 14.7 minus 0.1781. That will be P of dry air, which is used here in the definition of specific humidity.
So we can find the PV over
PT minus PV. Yes. Okay. So PW, this one, P of air, this minus this is written here. So that is specific humidity. Pounds of water per pounds of dry air. This is a very small number. So what we do, we multiply with 7,000 grains of water per pound of dry air. So we use grains instead of pounds. Okay. If you want, here it's find out the specific humidity. For that we have this formula, CPT plus this is CPT of dry air part, and that is vapor part. How much vapor is there, that depends upon omega, and that is the enthalpy of 1 unit mass of water. This is Hg plus CPT. All right. This formula is for English units, so just put values and find out the answer. So that will be BTU per pounds of dry air. Okay, that's how we derived that formula. Okay.
The final will use both units.
Yes, depending on if you get this problem, of course, it's English units. So you will solve it like English. So in these slides, you have questions in both English and SI mix. But the practice problems I took only from Stoker and Jones, and those are all SI. Okay. So instead of using these equations, we have a chart, right? That is called psychrometric chart, in which all these moist air properties can be shown conveniently. And we can use this universal psychrometric chart to solve air conditioning problems or to design air conditioning systems or to find out the moist air properties, right? Because now on this chart, the x-axis is representing dry bulb temperature, the y-axis is representing specific humidity, okay? And also you, in some cases, you will see a second y-axis showing vapor pressure, only water vapor pressure. Okay, so dry bulb temperature is on x-axis, so it means the dry bulb temperature lines are vertical. This is x-axis. So all these lines are representing particular dry bulb temperature. And dry bulb temperature is increasing in this direction and decreasing in this direction. Okay. It is like this, yes. Okay. The horizontal lines are representing specific humidity. Now the other lines, here is the relative humidity time. Relative humidity varies from 0 to 100%. So here this is representing saturation. Saturation means 100%. 100% relative humidity.
So dew point.
Yes, I'll come to dew point also. Then relative humidity decrease. Here you will have somewhere 0% relative humidity. These are relative humidity lines. Dew point and wet bulb. Now these are wet bulb. Wet bulb lines are like this. And the wet bulb temperatures are mentioned normally here on this curve. Dew point go horizontal to read the dew point on the same wet bulb temperatures, but wet bulb lines are inclined, dew point will be horizontal. Okay. At this point where air becomes saturated. Wet bulb also saturated. Okay. Okay. What else? But wet bulb means when you are adding moisture into the air. Dew point means you are not adding moisture. You are decreasing its temperature. Moisture is fixed. Look here. This is your air, for example. This air has this much dry bulb. Right? Wet bulb means if you add moisture in it. If you add moisture in it, so here specific humidity is increasing and the temperature will be decreasing. This, right? But this is now wet bulb temperature, not the same air as dry bulb and same air as wet bulb by adding moisture. But if you do not add moisture, you just cool it, then this will be dew point. You're just cooling it, but the same moisture, amount of moisture is not changing. Then you can read its dew point just by cooling it, cooling up to this point. Now whatever air, water vapor is there will start to condense. Okay, just by cooling it. So similarly, now you have volume lines, more sloped than wet bulb. Okay, so you will have volume lines like this. There are also enthalpy lines are very similar to wet bulb lines, but you will have a separate enthalpy scale here. So just extend this line up till here to read enthalpy. Right. So we'll be using that chart to study the moist air properties and to show different air conditioning processes with the help of that diagram. Okay, so we'll do it next time.